All right, so we're looking at inverse functions. And remember, the characteristics for two inverse functions is that the y's and the x's are interchanged. So if you look here, you have f and g, and we are going to find the unknown coordinates, assuming that f and g are inverse functions. Okay, so the coordinate -5, 4 on f is going to give me a function reversed, because it's the inverse on g, would be 4 comma -5. So that right there, let me get my color here, would be 4 comma -5. Okay, and then the coordinate -2, 5 on g, the inverse function, would give me 5 comma -2. And then 2 comma 8 will give me 8 comma 2. And then this function 13 comma 6, interchanging x and y, would give me 6 comma 13 for its inverse. So these two functions f and g are inverses of each other. Okay, do the same thing on these. Okay, I'll let you guys do number 2. I'm going to do number 3. So we got the coordinate -c comma -f. Well, the inverse would be -f comma -c. Okay, -a comma -g. If I switch them, it's going to be -g comma -a. And then -b comma h would be -h comma -b. And then that's going to be CF, EE, and AD. Okay, and number 4, if you were to look at your notes, if you're given two graphs, so the two graphs like right here, and I want to prove that they're inverses of each other. Okay, remember, you're looking for symmetry about the line y equals x. Okay, so I'm going to say symmetric about the line y equals x. Okay, so now let's go ahead and do that. So on number 5, if I was to draw the line y equals x, which is just a diagonal line, it goes through the origin, has a slope of 1, y equals x. I made these graphs easy so you can just go from one corner to the other. If I folded it on this diagonal, I folded it. This piece is going to line up with this piece. This piece will line up with this piece. So they are inverses of each other. Okay, do the same thing on 6. Okay, if I folded it on this line, this dashed line, boom, I should note that that is y equals x. That's the line y equals x. Okay, this is going to line up. This is going to line up. So again, this is a yes. So those functions f and g are inverses. Okay, number 7. Okay, that's the line y equals x. If I was to fold it, look what's going to happen. It's going to match up. Okay, and then you guys can do number 8. It should be obvious just by looking at it what the answer is. All right, it says show that f and g are inverse functions by graphing. Compare your graphs to the line y equals x. Okay, I'm going to let you guys do number 9. I'm going to do number 10. Okay, now before I graph g of x, I need to kind of change it up a little bit. So I'm going to split it. I've got 2 over 4 and then minus x over 2. Okay, I'm sorry, x over 4. Okay, and then I'm going to rearrange it. So I've got negative x over 4, and then 2 over 4 is 1/2, so I'm going to make it plus 1/2. Okay, so I have a y-intercept of 1/2, and I have a slope of negative 1 over 4. So I'm going to graph this one first, though. So I'm going to switch it around because we're used to mx plus b. So I'm going to put the mx in front. So let's go ahead and graph 2. And then it says to go down 4 and right 1. So down 1, 2, 3, 4, and right 1. And then can I go down 4 again, right 1? I can't. Can't go up 4 and left 1 either. So now I'm going to go ahead and create my line. Okay, let's see. Do I have a line tool here? I think I do. I'm going to try to, let me see if I can make that work. Maybe. How does that work? Oh, yeah. Just make sure it goes through both points because I want it to look good. All right. And then I'm going to go ahead and just draw my arrows. Okay, maybe I can select it and change the color. Looks like it moved. It did move a little bit, didn't it? Let's see. Oh, there we go. What happened? It's not letting me change the color. Oh, whatever. All right, so now I'm going to graph this one. So I've got 1/2. So that's 1/2. And then it's down 1, right 4. So I'm going to go down 1 and then right 1, 2, 3, 4 right here. And I'm going to go up 1 and left 1, 2, 3, 4 right here. Okay, and then I'm going to draw my line. I'm going to change the color on the line. Make sure it goes through the points. Go back and select it. Oh, not that. I don't want that. I want it to go through half. So half is right about there. Right about there. Okay. And then I'm going to go ahead and draw my arrowheads. Okay. And then we want the line y equals x, which is just corner to corner. Okay. Y equals x. So if we folded it right there, this part is going to line up. This part will line up here. And so they are inverses. Let's see what it's asking us. Compare the graphs to the line y equals x. So here I'm going to say we're comparing, and I'm going to say symmetric about the line y equals x. Boom. Okay? And it should be symmetric about the line y equals x on 9 as well. You're just graphing. So it says here, find the inverse of the function f. Use Desmos to graph both f and f inverse to verify that they are inverses. Okay? So let's go ahead and find f inverse. So the first thing I do is I make this y Then I interchange y and x. And then I solve for y. So I'm going to bring the 3 over, the minus 3. That makes it x plus 3. Then I divide both sides by 2. So I end up with x plus 3 over 2 equals, and then these reduce to 1 and become y cubed. And then I need to get rid of that third power. And the inverse of a third power is a third root. So I take the third root of both sides, and then there I have it. So that cancels. I end up with y equals this, but I'm going to write it in inverse notation. So I'm going to say f inverse of x equals this third root of x plus 3 all over 2. Okay? So now let's go ahead and check it in Desmos. So I'm going to graph 2x cubed minus 3. Okay, so 2x cubed minus 3. And then I got the cube root. Move this guy. There we go. So let's see, I need a root. Somewhere. Right here. Oh, I'm the wrong one. So I need a third root of x plus 3 over 2. So in here I'm going to do division. I'm going to hit my division sign and then do x plus 3 over 2. Hey, look at that. Now let's graph the line y equals x. There it is. I can make that a dash line. And look at that. It's perfectly symmetric about the line y equals x. Sweet. Okay. So you guys can do number 12. You guys can do number 13. You guys can do number 14. And then let's take a look over here at number 15. So we're going to find F composition G inverse. So the first thing we're going to do is find F composition G. So F composition G is F of G of X. So that's F of 2x plus 1, which of course I'm going to take 2x plus 1 and plug it into F. So that would be 2x plus 1 plus 2, which is 2x plus 3. So that's F composition G. Now I define the inverse, okay, because that's what that negative 1 stands for. Just find the inverse. So I'm going to make this a y, and then I'm going to switch them, interchange x and y. Okay, bring the 3 over. Divide both sides by 2. So I end up with this being the inverse. Okay, so I'm going to write the notation that F composition G inverse equals x minus 3 over 2. Okay, now we should be looking at domains, okay, but there are no restrictions here, so because they're both linear functions, so the domains are fine. just all real numbers. You look over here, like the third root, you're allowed to take third roots. It's just if you have an even root. Even roots have restrictions. Okay, but odd roots do not. Okay, so this one will end up having a restriction. Okay, so hopefully you guys can finish the rest.